Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, guys. Good morning, girls. Welcome to grade 9 geometry. Today, inshallah, you will study a new lesson which is space, figures, and cross sections. Space, figures, and cross sections. Okay. First, you must know what about space figures. Space figures. I think this meaning refer to what? Refer to figures in the space which has three dimension. Okay, like what? Like, yes, good, like cuboid, like this figure, for example. Okay, like cube, like cuboid, like sphere, like prism, and so on. Okay, so let's go to this figure. This figure is called solid with three dimension. So this figure is called space figure, space figure. Okay, and you and it has another meaning, another concept, which is polyhedron. Polyhedron. Okay. What about polyhedron? Polyhedron is a three-dimension figure or space figure. Space figure. Okay. This polyhedron contains some concepts, some main concepts. For example, by red color. Okay. This by red color is called edge. Edge. Okay. But what about this point? This point is called, yes, good, vertex. Vertex. So we can say, what's the meaning of edge? Edge is a line segment joining two adjacent vertices. Edge is a line segment joining two adjacent vertices. Okay. What this is called? Edge. It's called edge. Okay. And vertex is the intersection point of two edges or more. Two edges or more. Okay. We have another definition for this shaded part. Okay, this shaded part like polygon. Yes, like its base or the side of this polyhedron. So the shaded part here is called face. It's called face. Okay, so now I can ask you about number of faces, number of vertices, number of edges. Number of faces is count, yes, yes, good, 6. Okay, how to count 6? Okay, you have two faces up and down. Number 1, you have two faces opposite and behind. We have two faces right and left. So you have 6 faces. You must imagine. Okay. How many vertices? Count. 1, 2, 3, 4, 5, 6, 7, 8. So number of vertices is 8. Okay. What about number of edges? Count. Okay. It will be 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, 12. Then number of edges is 12. Okay, here we noted that if we added number of faces and number of vertices, it will be, yes, 14. 14 increased by 12 by what? By 2. So now we can say F plus V, number of faces plus number of vertices equals number of edges plus 2. Yes, plus 2. What this? Yes, this is new rule, new formula is called Euler formula. Euler formula here for polyhedron or three-dimensional figure. Euler formula for polyhedron is number of faces plus number of vertices equal number of edges plus 2. So now we can say number of faces plus number of vertices equals number of edges plus 2. Okay, again, what's the meaning of polyhedron? Polyhedron is a space figure or three-dimensional figure whose surfaces are polygons. Each polygon is called face. Is called face, like this one, and so on. Okay. And an edge is a segment that is formed by the intersection of two faces. Okay, like this one, like this one, like this one. Okay. What about vertex? Vertex is a point where three or more edges intersect at it. Okay. For example, how many vertices, edges, and faces in the polyhedron at the right, and list them. First, how many faces? Count. Okay, here you have, yes, one face in the bottom and four faces, four side faces or four lateral faces. So how many faces? Five. And how many vertices? You have five vertices because you have H, F, E, D, and G. So we have five vertices. Okay, which are H, G, D, E, and F. Okay, but how many edges? Okay, you can add, you can count them, or you can apply your rule. Euler formula, Euler formula. Euler formula is F plus V equals E plus 2. F plus V equal E plus 2. So we can say 5 plus 5, 10. Okay, then we can say 10 equal number of edges plus 2. Then how many edges? Yes, good, 8. And you can count them from the figure, from the polyhedron. Okay, count with me. Okay, one in the back. Okay, dashed. This one. Then 2, 3, 4. Then you have other 4 edges down. So you have 8 edges. Okay. which of which of them is, for example, what about edges? HE, HF, HG, HD, FE, ED, GD, and the last one is GF. Okay, what about faces? You have 5 faces. Okay, list them. Okay, you have 5 faces. Okay, the last one, the first one is the base. The base here is a quadrilateral, is a polygon, okay, which is GFDE. And you have 4 side triangles. Okay, for example, triangle HEF. Okay, in the right, HEF. For example, HGF, HGD, HDE. So you have 5 faces. Okay, next. Okay, this Euler formula, sum of number of faces and number of vertices equal number of edges plus 2. Okay, for example, this figure, yes, okay, we said that before, but what about the net of this figure? This figure, if you folded this figure, it will be this figure, okay. But I want to apply Euler formula on the second shape, the two-dimensional figure. Okay, first I need to find number of faces, number of vertices, number of edges. Okay, count. What about number of faces? Number of faces, 1, 2, 3, 4, 5, 6, 7, 8. Okay. What about number of vertices? Count. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Then number of vertices is 22. Then number of edges, 1, 2, 3, and so on. If you count them, it will be 29. Okay, excuse me, check if Euler form is correct in this case or not. Okay, Euler formula is F plus V equal E plus 2. Okay, So we can say 8 plus 22 equals 29 plus 2 or not? Check. The first side is 30. Second side is 31. So Euler formula according to polyhedron different for Euler formula for two-dimensional polygon. Okay, but these two, it will be one. So we have two rules for Euler formula. Euler formula for two-dimensional figures and three-dimensional figure. In the two-dimensional figure, we can say f plus v, number of faces plus number of vertices, equal number of edges plus 1. But in the three-dimensional figure, like polyhedron, we can say number of faces plus number of vertices equals number of edges plus 2. Number of edges plus 2. Okay? This Euler formula. Okay, good. Okay, and the last idea here, a cross section. What about cross section? Cross section is the intersection of a solid and a plane. For example, this prism, this yellow, this blue prism and yellow rectangle. Okay, what about intersection between them? Intersection between them, yes, good. Triangle. What this? This called cross section. Cross section. Okay. Okay, some exercises. Okay. Number one, how many faces, edges, vertices in the solid? Okay, first, how many faces? Yes, we have one side, right? Okay. And you have four. Okay, four other. Okay, so how many faces? 5. How many edges? Okay, you have 4 and 4 down. Then number of edges is 8. How to find the number of vertices? Okay, count them. Number of vertices is 5. Okay. And list them, for example, faces like polygon BCDE and triangle ABC and triangle AEB and so on. Okay, what about vertices? Vertices are A, B, C, D, and E. What about edges? AC, AB, AE, EB, BC, and so on. Okay, this number one. Number two, what's the net for the solid in exercise 1? Verify Euler's formula for the net. Okay. First, what about net of the solid? Net of the solid, if you stretched this solid, what about net of it? Okay. Net, it will be, first, you have quadrilateral, like this. And you have 4 triangles. Okay, like this. Like this. Okay? Okay, but what about verify Euler formula for the net? Sure, we know in this two-dimensional figure, we can say number of faces plus number of vertices equal number of edges plus 1. Good. Number 3, what's the cross-section formed by the cube and the plane containing the diagonals, a pair of opposite side, opposite faces? Yes. Yes, good. Is a rectangle inside it. Rectangle inside it. Okay. Thank you for listening and meet you after, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.